Hello everyone. Okay, so this video we're looking at transformations of complex numbers on the Argand diagram. So there's kind of three key transformations you need to know. The first one you need to be aware of is if I multiply a complex number by I am rotating it counterclockwise by 90 degrees. And if I multiply by a real number greater than 1, I am stretching my number. And if I multiply by a number less than 1, I am compressing my complex number. But just as much to me to say it, let's go have a look at it in GeoGebra. Right, here we go. So we're in GeoGebra now. So let's look at this. I have a complex number here, z, right? I said here z is equal to 1 plus I. Now look what happens here. I have my scale factor here in the corner, k. Look what happens if I multiply it by like 10, right? This now has stretched my complex number up to here. Now it's equal to 10 plus 10i, right? So let's make my complex number a bit different here. So let's say I have 2 plus 5i, something there. Let's look at rotations, right? So if I multiply now this blue line, this number here, by I, it's going to rotate it by 90 degrees. So I'm going to put I in here. I put it here. Look. It has rotated 90 degrees. It has measured 90 degrees in here. And that doesn't stop, and that doesn't end. Because what if I just multiply by I again? My number now is 180 degrees counterclockwise. What if I just multiply it by I again? I've now gone 270 degrees. Then if I multiply by I one more time, we should be back to where I started. So I did a whole 360 degree rotation. So that is what we just need to be aware of. When we multiply by I, we are moving 90 degrees counterclockwise. So I'll show you that one more time. So let me just say my complex number is equal to 2 plus 0i. Multiply by I, it gets rotate counterclockwise 90 degrees. Like so. Easy peasy, lemon squeezy. Right, so now let's have a look at some multiplications. So I'm going to have 2 plus 3i here. 2 plus 3i. So get rid of the multiplication there. So there is my complex number I. I'm going to multiply that now by, say, 1.5. Right, when I multiply that by 1.5, it's stretched my complex number up, and then when I multiply it by a number less than 5, it compresses it down here. Then if I multiply by a negative number, I am going down here. So I'm actually going across the origin point here. So if I multiply, say, by -2, it now stretches it, but stretches it in the opposite direction. And there are the key transformations you need to be aware of. So let's go back to the main page now, and let's do some questions. So this is from a mock paper. This is from a mock paper. The complex number z is shown on the Argand diagram. Write down the coordinates of z. Well, that is going to be 3, 4i. So z is equal to 3 plus 4i. Plot iz on the Argand diagram above. So I'm plotting I. So I'm multiplying that number by I. So I know I'm doing a 90 degree rotation. So you can do an actual 90 degree rotation counterclockwise if you want. Or you could just multiply in the I. So I times 3 plus 4i. It's going to give me 3i plus 4i squared, which is minus 4 plus 3i. Minus 4 plus 3i, which is up here. And as we see, if you measure the angle between these 2 points, it is 90 degrees. So, There we go. I just did part 3 without even reading it. By joining both z and iz to the origin, describe the transformation, translation, rotation, or symmetry that occurs when multiplying complex numbers multiplied by I. It rotates counterclockwise by 90 degrees. It rotates counterclockwise by 90 degrees. So let's look at this one here. Write down Z1 in the form A. So this is from another mock paper the year before. Write down the complex number Z1 is shown on the Ergon diagram. Write down Z1 in the form A plus BI. Well, that's going to be 2 plus 3i. It's 2 on my real axes, 3 on my imaginary. Given that Z2 is equal to 2 times Z1, write down Z2 in the form A plus BI. So that's just 2 times this number, which is 4 plus 6i. Then finally, show IZ2 on the Ergon diagram. So, IZ2 is equal to I times 4 plus 6i, which is 4i plus 6i squared, which is going to be minus 6 plus 4i. Minus 6 plus 4i is up here. And there is that point there. So, just to make a note of the transformation for Z2. So see, Z2 is 2 times Z1. So I am actually stretching it out by a factor of 2. So this is going to go from here to here. So I just stretched it out by the same distance there. So the distance between these 2 points is equal there, but that's not that important, right? So by a factor of 2. So there was Z2 there. And then just by observation, when we plot them together like this, it does make a 90-degree rotation counterclockwise. And that's all the exam questions I have. I hope this video was some help to you guys. And I'll catch you guys later. Bye.